One of the interesting features added to C# 8 is the default interface methods. With default interface methods, developers will be able to promote the use of methods between unrelated classes. The main benefit of using default methods with interfaces is that it is possible to add a new default method to an existing interface without breaking the classes that implement that interface. In other words, this feature makes it optional if you would like to implement or override the method or not. Let's go ahead and see this. Okay, the very first thing that I'm going to create is an interface called iCar, and iCar has two methods that needs to be implemented. The first one is void, to make it public, void start, and public void run. And I'm going to create a new class called class Ferrari, and this Ferrari class is going to implement the iCar. Okay, as you are expecting that the class Ferrari needs to implement these two methods. If we take a look at the error in here, it's telling you that Ferrari doesn't implement interface member iCar start and iCar run. And Visual Studio is helping us, and we can just go ahead and tell it to implement the interface, and it will add the implementation for the two functions or methods without us doing anything, which is very interesting, but that's not what we're looking for. What we're going to do is the new feature or the updates in the default interface member is that we can go ahead and add a default implementation to this function here, start or run or even any function that you would have, so that if you didn't create an implementation, it's going to call this default implementation by default. Let's go ahead and try to do this. So the start in here, I'm going to tell it that this is going just to display a message that the car has started. Okay, give me one semicolon. So by adding this, it's going to implement it. If I did not implement any function here, let's take a look at the error. Now it's displaying only one error, which is the iCar.run, because it has no implementation in the class and it has no default implementation in the interface. We can go ahead and do something very interesting. We can go ahead and create an overloaded function, so public void run, and this time it's going to have a parameter, maybe double car speed, and this one is going to have a default implementation. So I'm going to display console.line, and I'm going to display car is running at and the car speed, and that's it. So if I take a look at here, again no error, because these two, the run method with one parameter and the start, has already default implementation. Let's go ahead and see this in action. So in the class, I'm going to create an implementation. I'm going to leave Visual Studio to create the implementation for me. So implement interface. I'm just going to remove this one and add my message car is running. Just something very simple. This is the implementation for the run method without a parameter. Okay, let's go ahead and the main function here, and I'm going to start using all of these that I've created. So I'm going to tell it iCar, maybe F1, that's a model of a Ferrari car, I guess, formula, I believe, equal new Ferrari. Okay, I can now access the F1 dot. As you can see, I have the run, and I have two overloaded methods, the one with a parameter and the one without a parameter. And as you can see from here, there is two different implementations, one in the class and one in the interface. Going to the first one, and I can go ahead and use the start to make sure that everything is working very smoothly. Maybe the start is first, then the run. Okay, let's run this and see the output. So here it is, car has started, car is running. I hope you are following with me. If you would like to define this instance from the class itself, we're going to do a trick in here. So I'm going to create Ferrari, I don't know, maybe spider equal new Ferrari. And in order to be able to use the default implemented methods in here in the interface, the start and the overloaded run, we are going to need to cast this instance to the iCar interface. So let's do this. So in here, I'm going to tell it iCar, and I'm going to type the name of the instance. And right now, I'm going to be able to use the run, the two runs, and the start. Okay. If I try to do this without casting, it will not work as you would think. So we have only one function or method in here, which is the run, that is implemented natively in the class Ferrari. So let's go back, and here it is. And I can go ahead and cast it. Let's try it. Let's pass the speed maybe 200 kilometers or miles. It's not the start, it's the run. Okay, let's go ahead and run this. And here it is. Everything is working very smoothly. One of the features also is that you can go ahead and add modifiers. You can go ahead and add public, as you have seen me doing in here. I can go ahead and add private. Going to work. I can go ahead and, no matter what the case you would like to do, but this is something that you can do right now with the new C#. So that was the default implementation member, one of the amazing features that has been added to C#. As you can see, this error now in here because it's inaccessible due to its protection level, because I changed this modifier. If I make it back to public, it's going to be gone. So that's it, and see you. Welcome back everyone. In this video we're going to see how to work with nulls in C#8, because there is some neat tricks that have been added to work with nulls in C#8. So let's get started. Okay, what I have in here is a class called employee with 3 attributes: employee ID, employee name, employee job, and they have a constructor that is initializing the employee ID and the employee name with 2 parameters passed to it when we are creating an instance. And in the main method, I have a variable or an instance called Jack from the class employee that we defined up here, and I'm just passing the ID and the name. And here I have one static method that is capitalizing the job of the employee. Right now this code seems peacefully correct. As you can see, there is no error, no warning, nothing. But if I try to run this, it's going to boom, give me an error in here. Object reference not set to an instance of an object. It didn't work. There is some kind of a problem in here. And the problem is, if you have noticed, is that I am trying to capitalize or make it uppercase of the field employee job, and I have no employee job in here supplied. I did not pass the value of the employee job, and the compiler didn't catch it. So I need some kind of a warning to tell me that this field you didn't provide, so that I don't have a problem on runtime or on production in some cases. You might think that this is very easy, piece of cake, you can catch it, but this is only one file. This is very basic. It's only 1 or 2 classes with some 3 attributes. That's nothing. If you have some larger project with many classes and many attributes, it would be easy for you to leave some kind of a property not filled or something. We have to find a way to fix this, to notify the developer as he is working, to catch this scenario as he is working or she is working. So the first thing that I would like to show you is that we can go ahead and define this as nullable string by adding this question mark. This means here that this property, the employee job, is going to be nullable string. If I check it back here, it's telling me that it's nullable string. This question mark means that it can be null. Okay, but it didn't quite help me. It didn't get the error. What I'm going to show you is pretty neat. Let's go ahead and from the Solution Explorer, right click on the project, click on Edit Project File, and in the property group, I'm going to add a new value or property. I'm going to type nullable, and I'm going to type enable, not enabled with a D, only enable. Let's go to the program, save it, and build. you might think that nothing has changed, but something has changed. If we go all the way down, now the compiler is aware of that this property, this attribute, the employee job, can be nullable and I did not handle it. So it's giving me the warning. Take care, you might have a problem on runtime or in production with this property. So I can fix it. I'm going to type it in here. Employee job equal null. And in here I'm going to fix it. If employee dot job is null, go ahead and return string dot empty. Now the error is gone, and if I did not add this in the beginning or I forgot, the compiler now will let me know this. And if I disable this, I type disable to check for nullables, now it will not notify me about the potential error that can happen on runtime. So you can control it per project. But what if I wanted to control it, but only for a file? If I have multiple classes or files and I would like to deactivate it for this file, I can just go ahead and here on the top of the file, I can go ahead and add nullable, disable warnings. Save this, and as you can see now, the warning has gone. Also, I have the nullable enabled in the project file because it was disabled for this specific file, and I can go ahead and make it enabled again, and it will be back. It's not being displayed right now because I have handled the error. Okay, if I command this, it's going to be displayed, enabled, it's going to be enabled again, as you can see. So let's fix this before we go. This is the nullable that we can work with C#. I think it's pretty neat. Plenty of other languages has this feature earlier than C#, but it is here with C#. We can use it. One thing that I would like to show you is that we can enhance this even more. I can just go ahead and remove this and use lambda expression. I can go ahead and tell it that employee dot employee job dot to upper, and 2 question mark mean that if this happened, go ahead and let's remove this first, and I'll show you what I did. So what I did here is just I used some techniques with C#, the lambda expressions. I believe that you're familiar with it, and this simple in here, it's just asking if there is a value in here, it's going to be displayed. If not, it's going to display string.empty. But as you can see, again, we have the same problem. We have a problem that this may be null, so we can just fix it without the if condition, only using a question mark, telling the compiler that this might be nullable. I think that's pretty neat. So in order to try it, let's go ahead and try to create another constructor, ctor, for an int id string name string job, and the employee id equal the id, employee name equal name, employee job equal job. Now I can go ahead and here and add one more parameter, maybe our job software developer, and let's take a look at the output. Maybe we just add this in a console.line so that we can see the output. Let's run this, and as you can see, software developer. If I did use the constructor with only 2 parameters, I can go ahead and see that nothing is being displayed, and I can just go ahead and add a message in here instead. No job. Maybe he does not have a job or something. That's just this, and here it is. No job. I hope that you enjoyed this and everything is clear for you. Let me know if you have any questions, and that's it. See you in another video. One of the very interesting operators that has been added to C#8 is the null coalescing assignment operator. Before C#8, we have seen how to use the null coalescing operator, But with C#8, we have a new operator called Null Coalescing assignment. Let's go ahead and check it. So I'm going to create a list of integers. I'm going to call it numbers. Let's go ahead and add the namespace. Equal new list of integers. I'm going to define a nullable integer called I. I'm going to set it to null. This operator is not a big deal, but it's really helpful in some situations. It's going to shorten your code. So if I would like to add numbers to this list based on a condition, if it's empty, I would like to add some specific number, for example, go ahead and add if and else and the old school that you are experienced with, but I can use this null coalescing assignment operator like this. So if the I question mark equal, for example, 5. So this expression means that if it's null, it's going to add the 5 to the numbers. Let's go ahead and see this. So I would like first to print the I, and I'm going to write value of I equal, and I'm going to display also what's in the list to number in numbers. And I'm going to display the, just go ahead and display it like this, so the number. Let's run this and see what it's going to give us. So it will give us the value of I is 5 and 5. This expression found that the I is null, so it set it to 5 without me doing anything. If the I had a different value, so if the I equal, I'm going to set a value before this expression in here. If the I is 2, for example, so now it's going to add 2 to the list, and the I is 2. And if I try to make 2 copies of these to show you the difference, I'm going to add 10 in here. So the first time the I is null, so it's going to take the 10. Let's go ahead and run. It's only displaying the 10, and the next time it also added 10 because it didn't add the 5 in here because this expression is false. The right operand is false. It's not 5, it's not null. So it's pretty basic, but it's very helpful. That's it, and see you. Welcome back, everyone. In this video, we're going to discuss using declaration. A using declaration is a variable declaration preceded by the using keyword. Its usage is different than using the keyword using that you have seen before in C#, as we're going to see. It tells the compiler that the variable being declared should be disposed at the end of the enclosing scope. These declarations enable shorter syntax for declaring disposable variables we want to dispose and clean our code. Let's go ahead and check this. Okay, the very first thing that I'm going to do is I'm going to create a new class called resource, and this class is going to implement an interface called Disposable. As you can see, the description provides a mechanism for releasing unmanaged resources. Let's take a look at the description and the documentation of this interface in here. As you can see, the same description as we have seen in Visual Studio, and here's some examples on how to use it, and there is the method called dispose. And if we read the remark, the primary use of this interface is to release unmanaged resource. The garbage collector automatically releases the memory allocated to a managed object when the object is no longer used. If you'd like to read more about the Disposable interface, I will leave this link for you. Let's go back to our app. And I will implement here 2 methods. Public void use, and this method is going just to display a message saying that using resource. Then I will create an implementation. Then I will create another implementation for the method dispose that we have seen, or that we need to implement. As you can see in here, this is the error that the interface is giving, because we have to create an implementation for this method, the dispose, which I'm going to do right now. just going to display another message, disposing resource. Maybe disposed. We'll see about this. Okay, let's go back to our main method in our class program, the default class created with this project. And what I'm going to create an instance of the resource. I'm going to call it resource equal new resource. And I'm going to call a function, one of the functions, so resource.use. And I'm going to display some message or something. Maybe this app is awesome. Okay, let's run this application right now. Okay, as you can see now, we are seeing the first message from this here, this use message using resource, and this app is awesome. This one in here. But this method was never called. The dispose. Remember the function of the dispose? Its primary function is to release unmanaged resources, and it was not fired. It didn't work until we call it. So I can come in here and just call it resource.dispose. Now it's disposing the resource. But that's not very practical. It requires that you dispose every resource that you're using after you finished it. It's not that smart. We needed a smart solution. So I'm going to comment this code in here, and I'm going to use a better version of this code. So I'm going to type using var resource equal new resource. The same as I did here, only added the keyword using, and that's the new keyword in this place. Using is already being used with C#, like in namespaces and when reading large files and connecting to a database, but this is a new usage for the using keyword. And I'm going to do the same thing, resource.use, and I'm going to display this message again. Just copied and pasted it. No need to write it again. Let's run this app right now. And as you can see, using resource, this app is awesome, and disposing the resource. The dispose method has been fired. Keeping in mind that I did not call it like in the scenario in here that I had to call it. Using the resource keyword, C# understood that after this resource is finished, it's going to release this unmanaged resource. Pretty interesting, I believe. Let's enhance this even more. So I'm going to comment this so that you see all three different types. And I'm going to use a totally different technique. Using, and between these two parentheses that I've written, I'm going to type var resource equal new resource. And I'm going to continue typing no semicolon resource.use. And again, I'm going to type this app is awesome. And let's see the difference. It was using the resource, and even before displaying this app is awesome, the next line or the next task that the program is going to do, it got rid of the unmanaged resource. It displayed the disposing resource. That's pretty clever, actually. And in these two scenarios, I did not have to call the dispose on my own, only by using the using keyword. Okay, that's it for the using keyword, and let me know what you think, and if you have any questions, go ahead and drop it. See you in the next video. Welcome back, everyone. This video is going to be a little bit advanced. It's going to look totally weird if you're not familiar with ref structs. We're going to discuss disposable ref structs. Just a quick refresher, a ref struct is basically a struct that can only live on the stack. Now, a common conception is that since classes are reference types, those live on the heap, and structs are value types, and those live on the stack. This is not correct. a normal struct can also be allocated on the heap. And we can discuss this later. I'm just trying to give you a quick overview of the reference structs if you are not familiar with the ref struct. Ref structs can do basically three things. It can be a method parameter, a return type of a method, and can be a local variable. That's for the ref structs. Now in this video, and with C# 8, we're going to see what disposable ref structs can do. Let's go ahead and check it. So I'm going to create a ref struct in here. So ref struct, and I call it car. And this struct is going to implement the iDisposal. Remember the iDisposal that we discussed in the previous video. And before we continue, there is some kind of an error in here. Let's read the error. As you can see, the car ref cannot implement interfaces. That's one of the disadvantages of using ref struct, is that you cannot implement interfaces in the first place. So how can we solve this? This is what the iDisposable reference structure or struct is solving. So let's comment this to see the difference between the two block of codes. And I'm going to type ref struct car, and I'm going to implement the method that we've used earlier, which is called dispose. And in here I'm going just to display a message. You can of course do any logic here if you prefer, but as you can see it's an empty program, so dispose method is called. Maybe small a, okay? So let's see what is going to happen when we create an instance out of this struct. So I'm going to use the using keyword that we have seen earlier, the using declaration. So using car equal new car, and in here I'm going to console.write line any text that you would like to add. My car is very cool. Okay, so we've used an instance or created an instance of this struct car, and there is a method called dispose in here, and it's not implementing in a direct way from the iDisposable interface. Let's run and see what is going to happen. And here is the magic. My car is very cool. Dispose method is called. So this is what the disposable ref struct is doing. It's just enabling you to use a dispose method, because the normal struct or ref struct cannot implement any interfaces, including the iDisposable interface. So I think this was quick and clear. Hope you get it, and see you in the next video. Welcome back everyone. In this video we're going to discuss one of my personal favorite newly added features to C#, the switch expressions. The newly added switch expressions can really make C# looks more beautiful. Let's go ahead and see how to use it. So what I have here simply is an enum called months. It contains all of the months, January, February, etc. And I have a static method called check months the old way, because that's the old-fashioned or the classic way of it checking or using the switch. I send it an enum and I switch on the months of type enum, and if it's December, January, February, March, it's going to be winter. April, May, June, it's going to be spring. July, August, September, it's going to be summer. October or November, it's going to be autumn. The default is going to be an invalid input, just in case. I know that these months can change from one country to another. Maybe in Australia it's different, and maybe other locations it's totally different. This is the most common and from where I live as well. So let's change this old ugly way to a more interesting way. So what I'm going to do now is I'm going to create a months of type enum months. I'm going to call it months equal months dot April, for example. And I'm going to display using the check months old way. You can go ahead and name it a better name than mine. I'm going to pass the months, not this one, the variable. And let's see the output of this. April should be a spring month. And here it is, it's a spring month. We changed it to maybe January. It's going to be the winter months, as you can see. So let's go ahead and try to refine this. That's good, but we can do even better using the switch expression in C#8. So what I'm going to do is I'm going to type public static string check months, and I'm going to pass a parameter of type enum months, and this is going to be a lambda expression, and in here I'm going to type months switch. Simple as that. Then I will be adding all the different cases between these two braces. So months dot January, it's going to display winter. Then take a comma, and months dot February, again it's going to be winter, and I can go ahead and take this as a copy and change the season. That's much faster. So we have here March, again is going to be winter, April, then in here we have April is going to be spring, and then we have May, not March. May again is going to be spring, June. I know that this is a little bit boring, but you have to do it. July is going to be summer. Then we have August, again summer. Then we have September, leave it summer. Then we have October, which is fall or autumn. And we have November, then we have December, and this is going to be a winter months. So we finished. One last thing that I would like to add is the default. The default with this new switch expression, only using an underscore like this, and you can go ahead and display whatever you want, invalid input or invalid months. And after you finish, just go ahead in here and add a semicolon, and voila, you're done. We replaced all of this with this. What do you think? Let's go ahead and test it. So in here I'm going to check the months using only the check months static method, not the old way. And the boss should display winter. So if I run this, winter. And if I try to change it to maybe November, and it's going to display the correct season. One last try. Let's go ahead and type March. It's going to be winter months. So that's how to use the switch expressions in C#8. See you in the next video. Welcome back everyone. In this video we're going to discuss property pattern. Property pattern enables you to match on properties of the object examined. It's one of the really interesting features added to C#8. Let's go ahead and see how to work with it. Okay, so what we have here is an enum called cities, and it contains a bunch of beautiful cities: Vienna, Berlin, Amsterdam, and to the end of the list. And we have a class called city. It has two properties: city name of type cities, the enum that we have declared in here, and the country name of type string, and the constructor that takes two parameters to initialize these two properties. One thing that I would like to mention, that there is Paris. When you hear the word Paris, you imagine France, but there is Paris in United States as well. Also for Melbourne, you will think about Australia, but there is a Melbourne in United States as well. Paris, I guess, is in Texas. Melbourne in Florida, I believe. We're going to use this, that's not some random information, okay? So what I'm going to do is I'm going to use this cities and countries to decide if this city is And prices, I'm discussing the prices, reasonable, above average, average, high, low, etc. Okay, let's go ahead and do this. So what I'm going to do is I'm going to create city. I'm going to call it Vienna. I'm going to add Astoria. And the two parameters is going to take the cities. The city is Vienna. And the country, I'm going to pass it as a string. I know that I could have done it with another enumeration for the countries, but I meant to do one with enum and one as a string. I'm going to use this or just demonstrate the difference. And the country is Astoria. As I told you, I need to specify the country because some cities, the names at least, does exist in other countries like Paris in this list and many more. Many cities names do exist in different countries. And I'm going to create city, Paris, France, one new city, and cities.paris. And then here, you can go ahead and type France. One last instance that I'm going to create is Paris, US, equal new city, that is the Paris in United States, cities. .paris, and then here I'm going to type USA, United States of America. So what I'm going to do is try to create a switch case that is going to check the city of the type enum and the country of type string and give you an overview of the accommodation, the prices in the city. Okay, so let's go ahead and do this. So get outside of the main, and in here I'm going to type public static string check prices, and it is going to get city. I'm gonna call it city. That the instance of the class city, and using lambda expressions, and I'm going to use the city and switch like we have seen in the newly added switch expressions in C#. And in here, between these two curly braces, I'll be adding again 2 curly braces for each condition. In here, I can go ahead and type city name, and these are the properties in this class. Again, I am sending a parameter, an instance of the city class in here. This class has 2 properties, the city name of the type cities and the country name of type string. Okay, that's why we can see that I have 2 properties, the city name and the country name. If I added one more in here, I'd be able to add it down there. Okay, so let's go ahead and define. That's very interesting, I believe. And with a colon and the cities, remember that this is of type enum, so the city, if the city is Warsaw, for example, in Poland, do something. And I'm going to type reasonable. I believe Warsaw in Poland is reasonable, the cost of living, I mean. It's a beautiful city as well. And add a colon in here to start typing another one. Again, curly braces, city name, cities, dot, maybe Budapest. Again, I think Budapest is also reasonable. Again, very beautiful city. Okay, let's do something different. Take the comma. And in here, when I'm going to add Paris, if you remember that city name is cities, Paris, there is 2 Paris. So I need to add one more attribute or property to this case in order to be able to get a correct answer. So country name, again, this is the string, so I'm going to type it. You can go ahead and define USA. This has to match what you have wrote in here. If that's USA and this is US, this is going to be totally different. Let's go ahead and try this. Let's add a semicolon in here. The last line, you don't need to add a comma. And I would like to display average, for example. I'm not really sure about this, I'm just guessing. And the I just copied and pasted this line. So the city's Paris and the country name this time is going to be France. That's pretty high. The cost of living, Paris is a very, very beautiful city, but it's very expensive. So if this is the last line that you're going to type, just go ahead and remove the comma and add a semicolon at the end. Now your expression is ready. As you can see, C# is giving me, the compiler is giving me a warning. The switch expression does not handle all possible embeds. We have seen this before. We can go ahead in here and add a default using the underscore. Well, and just go ahead and say invalid input, or type whatever you think is good. Now we have finished this check prices method. Let's go ahead now and try to see the result. So I'm going to display the check prices and I'm going to send it Vienna Styria, and we should have reasonable. Let's go ahead and test it. Invalid embed. So I'm sending the Vienna Styria to the function and I don't have a case for it. So maybe we'd like to change this. City is not covered. Let's go ahead and choose whatever text that you would like, and if we run this right now, we are going to see the city is not covered in this report or this statistical report. But if we add it in here, if we replaced Warsaw with Vienna and change maybe above average, let's run and see the message above average. Okay, you can go ahead of course and use the city. I can just type it in here. City.city name is. We can go ahead and add an is. That's more friendly. Vienna is above average. I mean in the cost of living. You can just go ahead and add it cost of living. Don't mean anything else. So as you can see, the cost of living. And we can go ahead and replace all of these texts. That's with the best is reasonable. And etc. I'm gonna leave it like this. So let's test it with something different. Let's test it with this. So console.writeLine, check prices, and I'm going to type Paris, France. Okay, let's run. Paris, France is high, if you remember. So here it is high. This is from the first check of Vienna. Now Paris is high, as you can see. If I have no, I'm going to comment this line, and I have no condition for this one. I only have Paris of the United States or in the United States. Do you think that this message will be displayed? No, it won't, because it won't fit the condition. It went to the default. City is not covered because it's a different country. Okay, it's very smart. But if I have one that has only Paris, let's test it. Go in here, I'm going to remove this command, and I'm going to choose only Paris. And I'm going to type this in here. City.city name, comma, city.country name is high. Let's test it. As you can see, Paris, France is high, the cost of living again, because it found one of the two Paris that I have. So I didn't provide in this condition, I didn't specify if I would like to check for the country or not. I checked only for the city, and the city already existed in this instance, it's Paris. But if I send Paris of US, and if we run right now, it's going to display is high, not average. Let's test it. Paris US is high. Can you imagine the reason? Yes, it is we missed the A in here. And I told you in the beginning of this video that this is going to be two different countries. That's not the best way to use hard-coded like this, but was just for the demonstration. Okay, it's better to have it in a class or enum or something like this. So either we remove the A from here or we add it in here. Let's run this now, and we are going to end up with the word average. Yeah, very good. So that's it about using the property pattern newly introduced in C#. I think it's very interesting and very powerful, and you can have a lot of fun with it. That would be it, and see you in the next video. Some algorithms depend on multiple inputs. Tuple pattern allow you to switch based on multiple values expressed as a tuple. If you're not familiar with a tuple, it's one of the amazing features of C#. It was recently added. A tuple is just a data structure that consists of a sequence of elements of different data types. We're not going to discuss tuples in this video. We're going to discuss the tuple pattern introduced in C# 8. I will leave the links for how to work with tuples for you if you'd like to check them. Let's get started. So what I'm going to do in here is the same as the previous video, just in a different way. I'm going to create a method to take the city and the country and tell me the cost of living and the prices in this city. If it's high, reasonable, average, etc. So let's go ahead and do this using the tuple pattern, of course. So I'm going to create a method called check prices. So it's going to be static string check prices. And the parameters for this method is going to be string city. It's going to take a city, and string country. So it's going to take a city, it's going to take a country, and then it will decide the cost of living or the prices in this city. One thing to note, that some cities do exist in two different countries, like Paris, for example. There is Paris in France, the most popular and the common one, and there is Paris in United States, in Texas, I believe. There is multiple cities that do exist, the names only, of course, in different countries. That's why we need to define the city and the country, and everything's different from one city to another, in one country in another. Let's go ahead and try to build this. So the switch case in here is going to be based on the city, and this is the format or the syntax for the tuple, if you are familiar with tuples. Switch. So this is how we write tuples. So we add the fields that we would like to filter based on, then we type switch, and in here, between these two curly braces, I will be adding the conditions. So if the city is, for example, Vienna, this is the city, and the country is Austria. I do mention Vienna a lot, I do love it. And then I'll display, no, not display message, just the string above average. Okay. Then we add a comma for the next condition or the next case. Then we can go ahead and specify Paris, France. That's pretty high. And the cost of living, I mean, it's a beautiful city, but it's very expensive. Then let's go ahead and create one for Paris in USA, and that's maybe average. Okay. And again, if we would like to add the default input using the tuple pattern, we just do this. In the switch expression and the previous video, we have seen the property expression, we only added one underscore like this. But with this, we need to specify the two of them to be two underscores like this. And I'm going to display invalid input. So go ahead and type whatever you want. So when you finish after the last closing curly braces, go ahead and add a semicolon and our function is complete. Let's go ahead and use it. So I can go ahead and here and type right line, check prices, and I can go ahead and type Vienna, Austria. Let's go ahead and copy this. And I'm going to change this to Paris. And here, Paris, France, and USA. And this one, of course, in here needs to match this one in here. If that's an US without an A, it's going to be a different country. So let's run this and see all of the messages. So we should have above average, pretty high, and average. So as you can see, we have above average, pretty high and average. If I try to remove this one, then this is going to be an invalid input because that's a condition that my function cannot fill or respond to. But I can go ahead and do something neat. I can come in here and add, this is Paris, and that's going to be nothing. And that's this Paris without a country. Of course, you will think about the Paris in France, and that's pretty high. Comma, and let's try this. And I'm going to run right now to see the result. So it's pretty high. Now my function is pretty smart. Know that this Paris is the French one, and it's pretty high. Okay. We can go ahead and try not only add 2 parameters in here, 2 fields, we can go ahead and add more. So I can come in here and start typing another method. So public static string check prices. It's going to be an overloaded method. String city, string country, and we can go ahead and add the language. And in the tuple expression in here, we're going to check based on the city, country, language. We're going to perform our switch. Don't forget the curly braces. So the first one that we can check first for, let's type Vienna, Astoria, and they do speak German. It's a different accent than the German in Germany, but they do speak German. And we can go ahead and display above average, comma, and let's take the next one, maybe Paris, France, and French. And that's pretty high. You can go ahead and create another one. I'm going to copy this just to lower the time. And this is going to be the USA one, not this one. This is going to be English, and it's going to be in the USA, and that's average. We can create even one for Paris only, the same as we did. So we can go ahead and create Paris. And that's going to be the popular pattern that we know. Again, no need to specify the language or the country. Pretty high. And if you'd like to add the default input, we can go ahead and add 3 underscores like this to have an invalid input. Invalid input. And the semicolon at the end. We can just leave this here, and again, console.writeLine, check prices. And I would like to supply the, let's test Vienna, the country, Astoria, and the language is German. We try this one. Let's just add a separator in here, just to know that we're using the new method. So as you can see, above average, that's for Vienna. If I try to add this, you're speaking English, now there is no pattern for this. There is no match for this condition in here, and it should display invalid input, as you can see in here. Okay, let's get it back to German. Let's try the last one. Check prices for Paris, USA, and language is English. This should be average. As you can see, it's an average in here. If I added something that is not correct like this for United States, if I didn't add this, maybe I would add FR for France, and this is FR for French, and run it. It will display pretty high. Pretty high. Because we have Paris. No need for these 2 inputs to display the result. That's why my method didn't care about these 2. It found Paris, so it displayed pretty high. Okay, I hope that you get it and you enjoyed this. It's one of the really cool features, these new expression thing in C# 8. So that's it about the tuple expressions, and see you in the next video. Welcome back everyone. One last new pattern that I would like to discuss with you in this video, which is the positional pattern. Some types include a deconstruct method that deconstructs its properties into discrete variables. When a deconstruct method is accessible, you can use Positional Pattern to inspect properties of the object and use those properties for a pattern. If you're not familiar with deconstruction, deconstruction is a process of splitting a variable value into parts and storing them into new variables. This could be useful when a variable stores multiple values, such as a tuple. I will also drop a link for you to read more about deconstruction if you are not familiar with it, because this pattern only again available if you have a deconstruct method. Let's go ahead and see how it works. Okay, so what I have in here for the Positional Pattern app is a class called point, and I have two properties, x and y. Imagine this as a game or something like this, where we have a position x and a position y. And then we have a constructor that is just initializing, taking two inputs and initializing the x and y, and I have a deconstruct method. Okay, let's go ahead to our class program and to the main. I would like to go ahead and create a new method. It's going to be static string display position. It's going to display the position from its name. It's going to take the point and we're going to work with this point. So we're going to do our switch on the point itself. So point switch. This point does contain properties, the x and y, as we mentioned earlier. So we can go ahead now and tell it if it is 0 and 0, this is going to be the origin or the original point, and I can go ahead and keep displaying. So bear with me, I know this is going to look a little bit complicated, so we're going to type var and the x, y, the two inputs for the position, when x greater than 0 and y greater than 0 also, to ensure that they are not with a minus number. Let's go ahead and display a message or do some logic if you are in a different situation. So current position is, and we're going to type the x and y. Let's go ahead and add the default. Maybe unknown position, something like this. Add a semicolon and add a semicolon in here. So based on the numbers that we're going to initialize, the instance with, it's going to display this message or perform this logic if we have different logic. So let's go to our main app, our main function, and we're going to create a point. Start point equal new point, and it's going to be maybe 0 and 0 because this is the origin or the start point, and I'm going to display it. Display position, and we're going to take the start point. Let's take a look at the output of this. It should display origin. Here it is. It's correct. Let's go ahead and give it another value, or maybe create another instance. Point, I'm going to call it only point equal new. I'm going to give it maybe 100 and 150. And again, console.writeLine, display position, and use the bind. Let's run this. And here it is, current position is 100 and 150, and if you keep changing this, it's going to change without a problem, and you can go ahead and keep asking if it's greater than 100 or 1000, you perform specific logic. One thing that I would like to mention in here is that without the deconstruct, if you're asking yourself, what is the use of this? If I just commented this out, now this expression is not going to work. Let's read the message or the error message. Point doesn't contain a definition for deconstruct, and no accessible extension method deconstruct accepting first argument of type point. It couldn't deconstruct or analyze what is this point. That's why this condition is not working, because I am sending a point in here. This point does contain 2 properties, can contain more, so to deconstruct it, we need to add this deconstruct method. I will leave a link for you for the deconstruction so that you can read about if you're not familiar with it. It's one of the newly added, not in C# 8, but it was added earlier to C#. Okay, I hope that you like this one. I know it looked a little bit complicated, but you can do it. If you have a question, I'll be gladly willing to answer. So that's it, and see you in the next video. Welcome back. Starting from C# 8, you will be able to apply the read-only modifier to any member of a struct. It indicates that the member does not modify state. Let's go ahead and see how to create read-only members in a struct. So before we start explaining what we have in here, this feature is not that huge. It's a small feature, but we have to cover it. So what I have here is a struct called point. It has 3 properties: the x, y, and the distance. And the distance, as you can see in here, it's auto-initialized or auto-calculated based on the x and y using this equation. And we have one method called display position that is calculating the distance based on the x and y, and if you notice that it is marked with a read-only modifier. That's why we can see this warning in here. The compiler is displaying this warning. Let's read the warning in here. It is saying that call to non-read-only member point distance.get from read-only member results in an implicit copy of this. In simple words, the compiler is giving you this warning because this method, the display position, accesses the distance property in here, which is not marked read-only. So it's giving you a hint in here. And this warning will be gone once you add the read-only. Like you to notice this. Once you add the read-only, now the warning is gone. Simply what is happening here is that the compiler warns you when it needs to create a defensive copy. The distance property does not change state. So you can fix this warning by adding the read-only modifier to the declaration, as we just did. I would like you to notice something, that the read-only modifier is necessary on a read-only property. The compiler doesn't assume get accessors don't modify the state. We have to mark it with the read-only explicitly. The compiler does enforce the rule that read-only member don't modify state. With this feature, it will let you specify your design intent so the compiler can enforce it and can make optimizations based on it. So, as I told you, it's a very small feature, but we have to cover it. So, that's it, and see you in the next video. Welcome back everyone. In this video, we're going to discuss static local functions. Starting from C# 8, you can now add the static modifier to local functions to ensure that the local function does not capture or reference any variable from the enclosing scope. Let's go ahead and check this interesting feature. So I'm going to start from the beginning. I'm going to create an array. I'm going to call it numbers equal new and array, and I'm going to specify actually the numbers. So 5, maybe 6 and 4. And I'm going to create a local function called add numbers. That's the call. And I can go ahead right now and create the function, the local function itself. So void add numbers. That's a normal function. It's not a lambda expression or something. And I can go ahead and create a for each loop var number and numbers. And I would like to display the number, and that's very basic. If we run this right now, we can see that we will have 5, 6, and 4. And if I change it one of the numbers, so if I go to numbers index number 2, which is 4 in here, that's 0, 1, 2, and set it to 0. If I run again, this array is going to change. There is no longer existence of the 4. Now it's 0. If I would like to prevent this behavior, I don't want the local function to access my or reference my variables and instance in this enclosing scope, in this scope in here, in the main, for example, in this example. We can simply go ahead in here, and that's a new feature, add a static void and the name of the method, or string, or any return type, of course. As you can see, once I marked this local function as static, it did display an error, not a warning, an error. And if we read the error, a static local function cannot contain a reference to number. So by adding this, you're just preventing the access to this numbers array to prevent it from changing. Okay, let's try something different. I'm going to create a function that's just displaying the first name and the last name, but I would like to create first string. So string first name Clark. It's not good that you define variables in two different positions in your code, but just for the sake of the simplicity of this example. So string last name Kent. So we have Clark Kent, and I'm going to create a function, return type string. It's called get name, and it's going to be a lambda expression, and the first name plus maybe add a comma or something, the last name. So what this lambda expression here is just taking the first name and the last name and adding a comma in between. Very simple task. And I'm going in here to display the result in a console.writeLine and get name. And I'm just going to run this, and as you can see, we have Clark Kent displayed. But what happened in here again is that this function, this local function, did access the first name and the last name. So if we added static, again, as we know, it's not going to work, and it's going to give me an error. Again, the same error. Static local function cannot contain a reference to first name, and the same for the last name. So how to fix it? If you'd like to pass a parameter, we can simply go ahead and send the parameters to the method and make it ready to receive these parameters. So I'm going to add string first, string last, and I'm going to use them in here. So first and last, and in here I'll be passing the first name and the last name. So let's test it. And here it is displaying the same result, and we prevented this method from accessing the first name and the last name variables by using the static to ensure that we don't access these variables by mistake, and we send it as a parameter in here, the first and the last, to ensure that we will not get access to this. I know it's not a huge feature, but it was recently added in C# 8. Maybe it will come in handy for you in some situations. So that would be it for the static local functions, and see you in the next video. Welcome back everyone to a new video. In this video we're going to discuss one of the most interesting features came with C# 8, asynchronous streams. C# 8 came with async enumerable. It's an asynchronous version of the existing enumerable. Now you can await for each over functions to consume their elements, then yield return to them in order to produce elements. And maybe that this sounds a little bit advanced, but we're going to present this in an easy way. But before we do this, let's go back a little bit and very briefly discuss the asynchronous programming. Asynchronous programming is a form of programming that prevents blocking of our application by allowing time-consuming work or tasks like downloading data from a network or reading large files, etc., to be decoupled from the main thread. In simple words, asynchronous programming is a form of parallel programming that allows a unit of work to run separately from the main application thread. When the work is complete, it will notify the main thread whether the work or the task was completed or failed. That's not actually new to C#. With C# 5, the async and await keywords have been introduced. I have covered all of these topics related to asynchronous programming from scratch in my complete C# course. These fundamentally improved how we can write and consume asynchronous methods. I'm still discussing C# 5 and the powerful two keywords async and await. And the advantage here is that the structure of our code can remain almost the same compared to synchronous implementation. So you don't have to change anything, almost anything. Nothing huge needs to be changed, but the compiler takes over a whole lot of work to reconstruct our code into mentioned callbacks to make it stateful and non-blocking, or simply asynchronous. But one of the drawbacks, methods producing streams of data, IEnumerable, the generic IEnumerable, were left out and required custom code to be written. However, such requirements are quite popular. Thinking of working with cloud applications, collecting data from IoT, receiving data from databases. But with C#8, long live the async enumerable. I will also leave a link or two for people who are not following what is asynchronous programming, because that's not the place to discuss asynchronous programming. And this feature added to C#8 is on top of what has been done before. So let's go ahead and present this new feature added to C#8. So I have a fresh new console app in here, and what we're going to do in here is going to look a little bit complicated if you are not familiar with asynchronous programming. So I recommend that you watch a video, read something about the asynchronous programming in C# before you start this video. So let's start. So what I'm going to do is I'm going to change the void, I'm going to remove it, and I'm going to add async, the keyword, and I'm going to add task. And it will ask about the namespace, and we're going to type it up here using system.threading.tasks, and that's it. And I'll be creating a method, it's a static method called IEnumerable get products, IEnumerable, and it is called get products. Just go ahead and add the namespace of the generic. Okay, let's keep it consistent with this pattern of typing a method. And I'm going to add the yield keyword with a return with just a very simple string getting products. The semicolon, I'll take this as a copy, add it a couple of times in here. Okay, and I'll be adding product 1, product 2, product 3. What is just happening in here is that I am returning each line of this, out of this, some kind of a product or an IoT service or an API, or something from a database. So this is going to be displayed first, then this, and that. Each time the get product is going to go back to the main and display this output. So let's see this using a for each, going for each prod and get products. I'm going to display it. I'm getting in here the result from here, the IEnumerable, and I'm going to iterate through it and display the product. Just as simple as that for now. And if we run this right now, it's going to work as we are expecting. Here it is, getting products, product 1, 2, and 3. That's not the new feature. That's already existed before. So what happened? What is the asynchronous stream that we have discussed at the beginning of the video? I'm going to create almost the same method. It's going to be static, but I'm going to make this method in here, the get products, asynchronous. So I'm going to add async keyword, and I'm going to use the new interface, asynchronous enumerable. Let's read the description. Exposes an enumerable that provides asynchronous iteration over values of a specific type. And this is the interface that we discussed at the presentation and the beginning of the video. And it's going to be of type string. Remove the 0. I'm gonna give it almost the same name, get products async, just to make it different. And what I'm going to do is I'm going to copy the same messages that is being displayed in here, the same logic if you're getting these products from a database or an API or something. And I'm going just to add a delay in here. So await task.delay as if it is taking some time, and I'm giving this time in milliseconds. If we take a look at here, it's in milliseconds. That's what it does take. So I'm going to give it 2 seconds, and in here 2 seconds, and in here another 2 seconds. Let's run and see the difference, but first let's add a separator in here. It's a very basic, simple separator, just dashes. And again, for each variable, prod in get products asynchronously and display the product. Okay. As you can see in here right now, I have an error. Because also something that I have mentioned in the presentation is this normal for each is not going to work with this, but we need to add the await for each. Now the compiler will understand that this task can be running in the background, getting some kind of data or something, and the control will go to the main thread, continue, not blocking our application. Let's test it. So as you can see in here, the first one finished, and right now it's getting the products, product 1, 2, and 3, assuming that this is the time that it took. So what we just in here is just we use this new interface, async enumerable, using the async and the await in here just to make a virtual delay. It's something not real. I'm just assuming that this will take some kind of time to be executed. And in order to be able to use it, we have to use the await for each loop. Okay, that would be it for the asynchronous streams in C#8, and see you in the next video. The next feature we're going to discuss is about delivering 2 new operators to C#, the index operator and the range operator, that allow constructing system.index and system.range objects and start using them to index or slice collections at runtime. In this video, we're going to discuss how to use the index operator or the hat operator. So let's start by creating an array. I'm going to call it cities. So var cities. It's going to be an array of strings, new string. And I'm going to define the values in here. So maybe just go ahead and type some random city. So New York. Go ahead and create your favorite cities. And Vienna, Madrid, maybe London, and Cairo. Okay, don't forget the semicolon at the end. What I would like to do now is to display the last item in this list, which is Cairo in here. So let's go ahead and try to display it. So cities, in order to do this, you can go ahead and type it like this. So this is 0, 1, 2, 3, and 4. So if I type in here 4, and if we run this, we're gonna have Cairo, but that's not smart. It's hard coded. If I would like to make it dynamic, I can go ahead and do this. That's more clever. Get the length of the array, so cities.length, and I'm gonna type -1. And if we run this right now, we're gonna have the same result, Cairo. And I think that you're probably familiar with this. If we added only the length, that's now 5, and it is start counting from 0. That's why item number 5 does not exist, and it's going to give me an exception in here. Index was outside the boundaries of the array. Okay, that's why we add the -1 to the length. So the created of this new operator, the hat operator, in order to be able to do this in an easier way. Much easier than this. It was already easy, but we can go ahead and see how to do this. So I can just come in here and type hat. This new operator is called hat operator, and type 1. Let's see the output of this. Cairo again. What is happening here? So let's first try to count this the correct way. So the normal count that we know is this is 0, then this is 1, then 2, bear with me, then we have 3, and then we have 4. That's what we already all know. But with the new hat operator, this one here is going to be the last record, which is going to be 5, because that's an array of 5. Then this item is going to be 4. Then this item is going to be 3. Then this item is going to be 2. Then this is going to be 1. That's why when we typed hat operator 1, it displayed Cairo. If I try to display number 3, this is going to display Madrid. Let's go ahead and test it. Madrid. Let's try another one. Let's try 5 maybe. It's going to display New York. Let's try New York. Here it is. If we tried 0, it's going to run an exception. Index was outside the boundaries of the array. The same as this counting here, starting from 0 and there is no 5. This one is starting from the end with 5 and there is no 0. Okay? It does also work with lists. So if I create a new list of integers, let's go ahead and add the namespace. This one, I'm going to call it numbers equal new list of integers. We can go ahead and fill it very quickly. Add 0. Just gonna give it a bunch of numbers 1, 4, 5. Just some random numbers. So if I would like to display the last one in here, I can go ahead and type numbers. And again, the hat operator, it's on number 6 on your keyboard. Shift number 6, and you're going to have this operator. And if I type 3, for example, can you guess which number it's going to be displayed? It's number 1. It's this one here. Because 0 is number 4, as we agreed. Then we have 3 in here, 2 in here. If we added 2 in here, we're going to end up having 4. As you can see in here. So it's a small operator, but it can come in handy in some situations. And we're going to use it next when we're working with ranges, as we're going to see. See you in the next video. Welcome back everyone. We're still continue to discuss the 2 new operators. In this video, we're going to discuss ranges or the range operator. So what I have here is an array called cities, the same as the one that we've created in the index operator app. And we're going to work with this, explaining how to work with range operator introduced in C# 8. So I'm going to create a new array. I'm going to call it copy cities. It's going to be a copy of this array in here using the range operator. So to copy this array into this one here, we're going to type equal cities, and I'm going to specify 0 ... This here is the new range operator 5. What does this simply do? It's going to take a copy of this array, the cities from 0, 1, 2, 3, 4, and it doesn't take this number in here, the 5. Let's create a loop to see the output of this. So for each city in copy cities, and I'm going to display the city. Let's go ahead and run. As you can see, we have all of the values in here. New York, Vienna, Madrid, London, and Cairo. If we were to do this here, 4, we're going to skip 1, which is the last one, Cairo. If we were to choose 3, we're going to end up with New York, Vienna, and Madrid, and it skipped London and Cairo. Okay, so that's 0, 1, 2, and it does not take the last number in here. In this case, it's 3. Is that it? No. We can go ahead and comment this. I would like to leave this commented. Take a copy, paste it in here, uncomment it, and we can go ahead and use the hat operator that we discussed in the index video. We can go ahead and do this. 5, 2, 1. Let's see how this is going to work. As you can see, we have from New York, Vienna, Madrid, and London. If we added it to the 0, we're gonna have the full list, as you can see in here. So it started from the back, 5, 4, 3, 2, and 1, and again this last number, it stops before it reaches this last number, the same as the 3 in here. And I can go ahead and make this from 2 to 0, which is going to take from this here to London and Cairo only. Let's run this. As you can see, London and Cairo only. I can go ahead and make this 1. You can go ahead and play whatever you would like to do with it. It's very flexible. Let's comment this, take a copy and comment it. I'd like to leave it for you to see the difference. We can go ahead also and do this to take the whole array. Only dot and dot. Or the range operator without any numbers. This is going to take the whole list in here. If we run this, it's going to take the whole copy. If we added a new one, maybe Tokyo, let's run, and here it is. It's also very smart. Again, let's comment this. I'm just leaving this here so that you can see the different select options that we have. I can go ahead and add a 1 in here, which is going to start from 0. This is 0, the beginning, to number 1, which is going to display only New York. If we run this, as you can see, it's only New York. And go ahead and make it 2. Now we will have New York and Vienna. Again, go ahead and make it 3. I'm repeating this so that you can see each pattern, how it is going to work with you. Okay, now we have Madrid. I can go ahead and add the number in here, so I can go ahead and add 1 in here and leave this as it is. So it's going to start from 1 in here to the end, which is going to display all the list except for New York. Let's run this. As you can see in here, all the list except for New York. It started from index number 1, which is Vienna in here, to the end. You can go ahead and make it from 0, the beginning, from New York to the end. I can go ahead and add, as we did in here, a limit or the end of this. I can go ahead even and define the range itself. Range is actually a struct inside of C#. So I can come in here and type range, as you can see in here. It's a struct, represents a range that has a start and an end. Okay, you can go ahead and name it whatever you want, city range equal, and the way to define it is the same that we type it in here. So maybe from 0 to 5. Okay, so that's the range. And I have the option also to see the start and the end in a dynamic way. So I can just go ahead and display city.range.start. It's a property. They can go ahead and also display the end to see the start and the end. As you can see, 0 and 5. If I changed it maybe to 2 or something, let's run this. 2 and 5. And the amazing thing here is that I can use this range to copy this list in here in a dynamic way. Let's go ahead and see this. So I'm going to create a new, maybe I'm going to call it new cities. That's my new cities that I'm going to copy, and it's going to be copied from cities, and instead of typing the numbers like we did in here, I'm going to use this city range, as you can see in here, and voila, it is working. I can go ahead and use a for each loop to loop through this, then use cities, the one that I've just created, and I'm going to display the city in here. Let's run this. As you can see in here, from 2 to 5 is going to end up with Madrid. That's 2, and here is 5, the last one. If I change it, of course, the array, let's copy all of the items. 6. As you can see, here is all of the items. There are 6 now because I added Tokyo, if you remember. So plenty of options. It's very handy tool operator that you can use in multiple situations. So that would be it for the ranges in C#, and see you in the next video.